So we are on section C, and this section comprises of short answer type questions of 3 marks each. So let's move on to the first one, 26. And it's given that the half of the difference between two numbers is 2. So let the greatest number be x and smaller number be y. Okay, so now according to the question, the difference between the two numbers is 2, so small greater minus smaller is equal to 2. And now the sum of the greater number, that is the greater number sum with y is the smaller number is equal to 13. These are the two equations, and we can directly subtract them to get the value of y. So this gets cancelled, and minus 3y is equal to minus 13 minus 2 is 11. So this gets cancelled. So this was x minus y is equal to 2, and sum of the greater plus twice the smaller number is 13. So if we subtract them, this gives us negative 3y is equal to 13 minus 2 is 11. This is negative 11. And we have to find the numbers. So let's find out the value of the sum of the greater number and twice the smaller number. Greater and twice the smaller number, the difference of them, if half of the difference it's given, sorry. So let me just write down these equations once again. So it's given that half of the difference between two numbers is 2. Read the question very carefully. So x minus y, that is the difference, and its half is 2. So that gives x minus y is equal to 4. This is equation 1. And now the greater number plus twice of the smaller number is 13. And we can directly subtract these equations, which gives us minus 3y is equal to minus 13. 13 minus 4 is 9, so this is negative 9, and y is equal to 3. So y is equal to 3, and from 1 we can get the value of x. So x minus y is equal to 4, y is equal to 3, so x minus 3 is equal to 4, which gives x is equal to 7. So our two numbers are x is equal to 7 and y is equal to 3. So we are done with the 26th question. And let's move on to the 27th, which we have to prove that root 5 is an irrational number, which obviously is an irrational number, but we have to prove it. And for that, we are going to assume that it's not an irrational, but it's a rational. Okay, for question number 27, let's say that root 5 is an rational number. So let's say it's a rational number. So let's say root 5 is uh, a rational. So let's give it a rational form. Let's say root 5 is equal to 3 by q, where p and q are co-primes. So by co-primes means that they have no other cofactor except 1. So they are not divisible by any other number. P and q are co-primes. Now let's cross multiply this, which gives us root 5 into q is equal to p. And if we square on both sides, so square on both sides gives us 5q square is equal to p square. So if 5q square is equal to p square, so that means 5 divides p square. And if 5 divides p square means 5 divides, and if 5 divides p, so if 5 divides p, let's say the quotient is c and remainder is 0. So the dividend p, now this implies we can write p as p is equal to 5 into c. So P is 5 into C, and if we replace we put the value of 2 in 1 we get. So P is equal to 5 into C, this is 5. And if we put 2 in 1, we get, if we put 2, that is the value of P in 1, we get 5Q square is equal to P is 5, C the whole square. Which means 5Q square is equal to 25, C square, 5, 5 that is 25. So Q square is equal to 5 C square, and this implies, what is the meaning of this? This implies that 5 divides Q square. So if 5 divides Q square means 5 divides Q. Now 5 is dividing both Q and both P. So that means P and Q are not co-primes because 5 is also dividing them. So that means but we have assumed in the beginning that P and Q are co-prime. So that means our assumption is wrong. So our assumption is wrong. Hence, root 5 is irrational. Okay, so this proves that root 5 is irrational. Let's move on to the question number 28. So let me erase this and move on to question number 28. So for question number 28, it's given that if negative 5, 3 and 5, 3 are two vertices of an equilateral triangle. So let's draw our plane. So let's say this is our plane and this is X and this is Y. So negative 5, 3 and 5, 3 are two vertices of an equilateral triangle. This is 0, 1, 2, 3, minus 1, minus 2, minus 3. And it's given that it's negative 5. So negative 4, let's say negative 5. So we have some negative 5, comma 3 here. And 5 comma 3 will be the first quadrant, let's say here. So if we join them now, then find the coordinates of the third vertex given that the origin lies inside the triangle. So this is our equilateral triangle, let's say with vertices A, B, and C. And C, we have to find out what are the coordinates of C. So because it's an equilateral triangle, so that means AB is equal to BC is equal to AC. So it is an equilateral triangle, and for the third vertex we have assumed that the coordinates are x comma y, so that means AB is equal to BC is equal to AC. Okay, we can easily find out AB, so let's find out AB. So using the distance formula, AB is 5 minus of minus 5, so this is 5 minus of minus 5 the whole square plus 3 minus 3 the whole square, which gives us 5 plus 5 is 10 square plus 0, which is 10. So AB is 10. So AB is 10, and let's equate BC and AC. So if I create BC and AC, so BC is, this is 5 minus x, or x minus 5 the whole square, whatever it is. So it is x minus 5 the whole square plus this is y minus 3 the whole square, and AC. AC is x minus of minus 5 the whole square plus y minus 3 the whole square. And this whole thing is under root. So under root and root gets cancelled if we square them. So now we have, this is x minus 5 the whole square means a plus b the whole square. So a square plus b square minus 2ab is minus 10x. This is a square plus b square minus 2ab minus 6x. This is x plus 5 now, which is a square plus b square plus 10x plus this is a square plus b square and minus 2ab, which is minus 6y. So x square gets cancelled, 25 gets cancelled, y square gets cancelled, and 10x, this should be actually minus 6y, this gets cancelled. Now minus 10x and 10x, and we have 9 and 9 gets cancelled, so it's minus 20x is equal to 0. So this gives us x is equal to 0. So x is equal to 0, we can find out. Now let's find out y, and for that let's equate bc to 10. So let's say bc is equal to 10. So this is bc, which is x. So bc square is equal to 10. So that means bc square should be equal to 100. And it's x minus 5 the whole square, bc square plus y minus 3 the whole square is equal to 100. Okay, x is 0, so this is minus 5 square is 25, and this is y minus 3 the whole square is equal to 100, and which gives us y minus 3 the whole square is equal to 100 minus 25, which is equal to 75, and y minus 3 is equal to root of 10 to 75, which will give us the value. So 75 is 15 into 5, and 15, so root 75, 15 is 3 into 5 into 5, which gives us plus minus 5 root 3. Okay, now we have two values, plus minus 5 root 3, because this is in the this lies, I think, because the x is 0, so that means this lies on the y-axis, so x is 0, and this is the negative value of y, so we will just consider the negative value here. So I'm going to raise this, and this is now negative because it's on the negative y-axis, so y is negative 5 root 3, and when 3 is shifted here, this is plus, so y is equal to negative 5 root 3 plus 3, and value of root 3 is 1.7, which gives me 7 5s are 35. So 17 into 5 is 7 5 are 35. 8 is negative 8.5 plus 3, which gives negative 5.5. So the coordinates y is negative 5.5 and x is 0. So our coordinate, the third coordinate, this one is 0 comma negative 5.5. Okay, this solves our question number 28, and let's move on to question number 29, first part. So let me erase all of these. Okay, so for question number 29, we have to prove that the two tangents uh, TP and TQ are drawn to a circle with center rho from an external point. We have to prove that PTQ. So for question number 29, now this OP is perpendicular to PT because radius is perpendicular to tangent at point of contact. So OP is perpendicular to PT at tangent of point of contact. So that means angle OPT is equal to 90, and angle OPT is 90. Angle OPT is comprised of OPQ and TPQ. So I can write it as OPQ plus angle TPQ is equal to 90 degree. Okay, so this gives me angle TPQ is equal to 90 minus angle OPQ. Okay, let's keep this as equation 1. Now PT is equal to TQ because tangents drawn from an external point to a circle are equal. So that if the tangents are equal, so then they're up, it's in the triangle PTQ. So that means angle PQT or TPQ. So if these tangents are equal, that means angle TPQ is equal to angle TQP. And this is because angles operate to equal sides are equal. So let's use the angle sum property in this triangle. So in triangle TPQ, so in triangle TPQ, angle TPQ plus angle TPQ plus angle PQT, TPQ plus angle PQT plus PTQ plus angle PTQ is equal to 180 degree. This is the angle sum property of a triangle. Now TPQ and TQP are equal. So TPQ and this is angle TPQ and PQT are equal. So for both of them, I can write angle TPQ. So instead of PQT, I can write TPQ. So this is PQT. Instead of PQT, I can write TPQ. So this is TPQ plus angle PPQ plus angle PTQ is equal to 180 degree. And this is 2 times angle TPQ plus angle PTQ is equal to 180. Now angle TPQ. So we have this angle TPQ is equal to 90 minus OPQ from 1. So I can write 2 times angle TPQ is 90 minus angle OPQ plus angle PTQ is equal to 180 degree. So if I open up the bracket, this is 180 minus 2 times angle OPQ plus angle PTQ is equal to 180. So 180 and 180 gets cancelled. So minus 2 times angle OPQ is equal to negative of angle PTQ. This gets cancelled. And finally, we have angle OPQ 2 times angle OPQ. So this is PTQ. So finally, we have PTQ is equal to 2 times angle OPQ. So PTQ is equal to 2 times angle OPQ. And this solves our question number 29's first part. And let's move on to the second one.